7.
Inverse of a matrix. Inverse of a matrix. So every matrix, for every matrix, inverse may not exist. If inverse exists, then it is called invertible. Okay. Let A is a square matrix. Let A is square matrix. Let A is square matrix. A square matrix such that A square matrix such that.
Sir, but we already finished inverse of a matrix, right?
No. A is how to find out inverse. Okay.
Okay, sir.
Let A square matrix such that AB equal to BA equal to I. Then B is called inverse of A. B is called inverse of A. And how do we write B equal to A inverse like this? Okay, this is what is inverse of matrix. And in this case, what will happen? Also, A is called inverse of B automatically. Inverse of B. Okay, how do we write that? That is, A is called inverse of B. A is B. Say equal to B. Side. Hope you are clear. If AB equal to BA equal to I, then only B is called inverse of A and A is called inverse of B. And here A, comma B are called invertible matrix. Inverse exists, then it's called invertible. Invertible matrices. Hope you are clear. The matrix is called invertible if inverse exists. So here very clearly, see, AB equal to BA should happen means A and B must be square matrix. Okay, if A or B is not square matrix, for rectangular matrix there is no inverse. For rectangular matrix, inverse we don't discuss. Okay, only for square matrix we discuss inverse. Hope this point is clear. Now, how do you find inverse matrix? How do you find inverse matrix? So here, for example, I will give you one example. What does this mean? Let A equal to, let's write 1, 2, 3, and some 4. Let's write 1, 2, 3, 4. Now, here there exists a matrix is there. B matrix is there. B matrix I write like this. I will make this more for the sake of easiness. I will make this more. Yeah, you will make it. Just a minute. I want to show simple example. Yeah. Yeah. 1 minus 2, 3, and 4. Okay, I wrote B like this. Now, what we see, now we can see that A is this, B is this. Now we can see that AB equal to what? AB, see, what is AB? Do AB, this row into this column. So 5, this is 5, and this is C here. This is this is
6.
right like this. Okay, this is.
So it will be -5.
Yeah, this is -5 plus 6.
6.
1.
Yes.
1, right?
Yes, sir.
The next is 5 to 10 minus 10, 0. And then this is minus 3 plus 3, 0. And this is 3 to 6 minus 5, 1. AB equal to 1. And we can also see BA. BA is what? BA you do this row into this column. Yeah? Minus 5, this is 6, 1. This is 0, 0, 1. What did you observe here? Here you can observe very clearly. Here AB equal to BA equal to I. Yes or no? You can observe this. So therefore, what
Yes.
you can say? Therefore, what you can say? A comma B are invertible. A comma B are invertible. A comma B are invertible and A equal to B inverse and B equal to A inverse. Okay. A inverse equal to B. B inverse equal to A. Okay. Understand?
Yes.
Here, but for every matrix, the question is for every matrix, inverse exists or not. Here you see A and B called invertible. That itself says that for every matrix, inverse may not exist. Yes or no? If they exist, then invertible. That means there is a case also. For every matrix, inverse may not exist. Okay. So therefore, note. We'll see that also. For every matrix, inverse may not exist. Inverse may not exist. Okay, for every matrix, inverse may not exist. Okay, if inverse exists, then it's unique. Then it's unique. Unique means what? Only one inverse exists. For matrix A, inverse is only one. One inverse only exists. It's not that for matrix A, 2, 3 inverse matrices exist. No, only one inverse matrix exists. Okay?
Yes, sir.
All right. So now, how do we find? Question is now, how do we find inverse? How to find inverse? How to find inverse is a question now. How to find out inverse for a given matrix? For square matrix, inverse. So first thing is for 1 by 1 matrix. Let's say let A equal to A like this. For this, what is the inverse?
The A only, right?
No. What is A inverse? A inverse equal to 1 by A. Na? You should get
Yes, sir.
A into A inverse equal to I you should get. Na? If you multiply, then you should get I. What is I? I is only 1 by 1 matrix, only 1. Okay, like this. So 1 by A, very simple. Na?
Yes, sir.
So for example like this. Let's say A equal to 3. So A inverse equal to what? Matrix 1 by 3.
1 by 3.
If you multiply these two, you get 1. Direct. This is direct anyway. So second, this is for 1 by 1 matrix. How to find out inverse? 1 by 1 matrix. So second, let A equal to ABC. A, B, C, D. How do you find inverse for this? Then, what is A inverse? Here is a shortcut. This will get later actually, but I am telling you. Here I am telling you, just for the sake of understanding, I am telling you A here 1 by AD minus BC, then D minus B minus C. Okay, that's what I actually here I wrote. That's the reason I could write fast with B. I could write B is A inverse. Na? I could write here fast by using this formula. 1 by AD minus BC, D minus B minus C by using this. This is A inverse. Okay, there is a formula for this is a formula and there is a procedure to find out it. Okay, but what is the usual procedure to find out the inverse of a matrix? So we will see procedure to find A inverse. Okay, so let's see this one. So here, first thing is, first we should learn elementary operations, because here what we do is AB equal to I equal to BA, yes or no? If at all A inverse exists, okay?
Yes, sir.
This is this is what we know, okay? Let's say AB equal to I equal to BA. So now what I will do is, first I will take AB. AB equal to I will take. Okay, AB equal to I will take. So then what I will do is, here we called elementary operations. Elementary operations. Here comes elementary operations. First I will explain what is this elementary operations. Okay, what is this? Elementary operations are transformation of matrix, or this one we can call transformation of matrix. Transformation of matrix. Transformation of matrix. Elementary operations you can say, or transformation of matrix you can say. So there are three elementary operations of transformation of matrix. One, interchanging of any two rows. In case columns, you can write columns. Okay, that means you can interchange any two rows or any two columns. This means bracket I put means or. Interchange any two rows or any two columns. If it is column operation, any two columns. If it is row operation, any two rows. So then next is two. Multiplying a scalar, or multiplying a non-zero real number. Multiplying a non-zero real number to any row or any column. If you are applying column operation, then column, otherwise row operation. The next, multiplying a non-zero real number but to a multiplying a non-zero real number to a row. Third one, multiplying a non-zero real number to a row and add it to corresponding elements of other row or a column also, and adding it to corresponding elements of any other row or column. Or just you can see this, what is the meaning of this. See, first thing here, interchange of any two rows or columns means what? Okay, I will take an example and I'll explain. See, this is, for example, matrix A. 1, 2, 3, 4, 5, 7, 8. See, first operation, what is the first one? The rows, let's say row operations. Okay, so we write like this: row 1, R1 means what? Row 1. Row 1 I am interchanging as row 2, and row 2 I am interchanging as row 1, like this. This means what? This means row 1 and row 2 are interchanged. Hope you understand.
So is it compulsory to interchange only the first two rows, or can we
No, no, no,
interchange
no.
the
Any,
rows also?
any two rows you can interchange. Okay,
Yes.
that means what? Then this matrix, transformed matrix becomes what? Then it becomes what? We write like this: transformed matrix becomes what? 4, 5, 6 became first row, and 1, 2, 3 became second row, 7, 8, 9 becomes third. As this third row is not changed. See, this is what is called the row transformation. Similarly, you can do column. Whatever we apply for row, we can apply for column also. Okay, this is
Yes, sir.
row transformation. Okay, this is called interchanging of two rows. How do we represent? Like this. In general, what we write is ith row we interchange to jth row, and jth row interchange to ith row. So any two rows can be interchanged. We represent like this. Any two rows can be interchanged. We represent like this. Okay, then what is second one? Second one is we can multiply a constant to any row. So here, what is that row we see here? We'll write row as like this. The R1 you can interchange as KR1. Okay, then this transformed matrix becomes like this. KR1, KR1 means what? R1. Let's say K as some 2 R1. Okay, 2 R1. So then it becomes what? C, R1. You can do the same thing with R2, R3 also. Any row can be multiplied with a constant. So then 2, 4, 6, and this becomes 4, 5, 6, 7, 8, 9, 10. Hope you understand. This is what is second operation. In elementary operations, we learn first operation is interchange of any two rows or any two columns. Second operation is multiplying a constant to a row or a column. That's what the second. And the next third operation we will do. What is the third operation? Multiplying a constant to a row R1 plus KR2. So I multiplied a constant to row 2 and added it to row 1. Okay. What is changed here? Row 1 is changed because I multiplied a constant to row 2 and added it to row 1. What is changed now? R2 is not changed like this. See, like this. Let's say R1 implies what I am writing? R1 plus 3R2. R1 is transformed as R1 plus 3R2. Now A becomes what is? See, R1 changed. R2 is same. What is R2? 4, 5, 6, 7, 8, 9. So what is changed you see here? R1 is changed. R1 plus 3R2. So R1. So what is R1? Now first element. R1. In this first element, what is the first element? 1. 1 plus 3 times R2, corresponding element of second row. Okay. We multiplied 3 to second row, added to corresponding element of first row. So corresponding to 4, there is 1. So 1 plus 3 times 4. You see here. Yes, sir. Here what you get? 13. Hope you understand. R1. What is R1 here? R1 was 1. In this R1, 1. 1 became 1 plus 3 into. Then next to here 2 was there. Right? 2 is there here, right? Here 2 is there now. How to change you see? 2 becomes 2 plus 3 times R2. R2 is 5. Okay, this is what is 2 plus 15, that is 17. Next R3, what was R3? 3. 3 becomes what? 3 plus 3 times 6. 18 plus 3. 20. Hope you are clear, right? This is
Yes, sir.
this is third elementary operation. This is third elementary operation. So the same thing I did with R1, you can do with R2. R2 becomes R2 plus something else. R2 is changed when you multiply a constant from 5 you multiply it to R3 and then you add it to R2. Then R2 changes. R3 will not happen to any R3 will not be changed. But R2 will be changed because you are multiplying constant to R3 and you are applying to adding it to R2. Okay. Or you can do like this. R3 implies R3 minus 2 times R1. You can do this also. Hope you are clear with this. All right.
Yes, sir.
Okay, these are the elementary row operations. Elementary operations with respect to row. You can do the same thing with elementary operations with respect to column. So now let's say quickly elementary operations. Elementary operations with respect to column. Elementary operations with respect to column. What is that? Column 1 or any column. Ith column you can interchange to jth column, and jth column. Ith column can be interchanged to jth column, or ith column can be transformed to jth column and jth column can be transformed to ith column. This is first one. Second one is any column can be multiplied with a constant. This is what is second operation. Third operation is you can multiply a constant to any column and add it to the other column. And that means corresponding element of the other column. K, C, J. Like this. With respect to column, this one. Okay, these are very important, very important. So now we are going to process. Okay, procedure. So procedure is what? AB equal to I or BA equal to I, what we should use. This is a way we find out, right? Now by using elementary operations, what we do? First thing. So let's take an example and see that. So first thing is A equal to, we write IA. This is what is true statement or not? This is true. This is true. A equal to IA, that's true. Now, if at all we want to apply row operations, now we'll apply row operations. Elementary row operations. Elementary row operations means what we should do, we apply on A. Here we apply on elementary row operations. If you apply, then what we should do, then apply on A and apply on A and also I. If you want to apply row operations, apply on A and also I. That's what the thing here. If you want to apply elementary row operation, then apply on A and also apply on I. Okay, this is what is row operations. So first you understand why is later. First procedure you understand. So now let's take now for example. What is the example? Let's take simple example. We'll take 1, 2, 3, 4. Okay, this is A. Now we'll start. A, this is 1, 2, 3, 4. Okay, equal to IA. What is I? 1, 0, 0. Okay, here again A. So that A I am not writing. That I am writing A only. I need not write this. Okay, now we apply. Next is write this. Okay, apply elementary row operations. Okay, elementary row operations you apply. So apply and then make it what you should make it I. This you should make it I. Then this will be some other matrix. Okay, that's the only inverse. Okay, now our aim is to make this one I, this matrix that is 1 0 0 1. Okay, by using elementary operations, what if you do? We have to make this matrix as identity matrix. Hope you understand.
Yes, sir.
So here 1, 2, 3, 4. We'll begin the process now. This is I. 1 0 0 1, and then this is A. Okay, right. Now we'll see this is anyway 1. I need not do anything for this one. For this 2 to become 0, first I'll make this first. What is the way you understand? First this one you have to make 1, then this one you have to make 0. This is a way. This is the way you should follow. This is one you should make, which is already there, but this one you have to make 0. How to make this 3 0 like this? Yes. R2 implies R2 becomes R2 minus 3R1. This is the official. This thing we should apply on both. Now you apply this one. This one you apply. If you apply this you have to apply on here and here also. Now R1 is not changed, 1, 2 same, but R2 is changed. See how it has changed? R2 minus 3R. R2 means this 3. 3 becomes what now? This 3. 3 becomes what now? R2 means this 3 and 4. Now this 3 becomes 3 minus 3 times 1. That is 0. See, that is the reason. No, that's the reason. R2 we are interchanging. R2 we are transforming as R2 minus 3R1. Why? To make this one 0. How do you make this 3? 0. 3 minus 3 times 1. Then only this is how you should apply. And then automatically this becomes what? 4 becomes what? 4 minus 3 times 2. R2 minus 3 times R1. R2 is here. 3 times R1 is 2. This becomes what? 4 minus 6 minus 2. This is wrong. Okay, that same thing you should apply here. R1 not changed. Understand? Very important. You understand this.
Sorry, sir, my laptop ran out of charge.
Okay, this is now we have to apply on here also. Identity matrix also. How it will be? You see, that's done. So we are applying here. Here we applied R2. Here we should apply R2. For R2 we should apply here. The 0 becomes what? 0 minus 3 times 1. That's minus 3. Then 1 becomes what? 1 minus 3 times 0. Understand?
1.
Okay, 1. This is a very simple. This R2 we are changing. That is 0 and 1 will be changed. 0 will be changed. 0 minus 3 times R1. Then 1 will be changed. 1 minus 3 times. So this is practice properly. So the next again, what we should do? 1 0 0 1. This we should make 0. This one we should make 0. How to make this? I am telling you, you should understand the process. First, this one you should make 1. Then this one is 0, and then you have to make this one 0, and then this one 1. Or you can do so. Come like this. First this one, then second this one, third this one, fourth this one. Okay, or this one third, this one fourth. No problem. These two, no problem. First, but you have to come 1 0. Okay, then 0 1. But anyway, here this one you have to make 0, and then this one you can make 0. So how do you make this one 0? So you add this minus 2 here. That is what? So to make this one 0, what I am doing, you see? Here R1 implies R1 transforms as R1 plus R2. Very simple. This 2 if you add, this becomes it. R1 is changing. R1 is changing. Now R1 plus R2. See how? R1. This is 1 plus 0 here. 1 only. Here this one plus this one. I am writing directly because it's easy. R1 I interchange 0 minus 2. You should not forget this one. You should. Okay, here you change. Now here also you should change. How? R1 means 1 becomes what? 1 minus 3. See, 1